Hello. So I recently have been working on developing the backend architecture for a Udemy-like site, and more specifically on the comments section of that site. So the data that I've been working with is reviews, courses, and users. And we're looking at roughly 10 million reviews and all of the associated data that comes with those. So I've been working on getting a system that could reliably and efficiently handle that amount of data. So I initially was looking between Postgres and MongoDB. I was looking a little bit more into MongoDB as it seemed that the overhead that's associated with a relational database and working with that nature seemed to be a bit impertinent as the transactions of reviews is not extremely sensitive. And so if um, maybe a review in its creation didn't go through right away or something was lost with that, it could easily be recreated versus obviously if you're sending something like money, you want to make sure that um, you're really keeping track of that data in every situation. So I was looking at using Mongo, and I realized pretty quick that a denormalized table is going to introduce some issues, especially since there's not a single source of truth for maybe the student or the course itself. So that way, if any of that information is changed, we would have to go back through all of the data points, find that data, and then update those each individually. So I started looking a little bit more into Postgres and the relational database setup of Postgres made it very easy to not only one normalize my database um, and add references, um, which made it very easy to if a user's name changes or their photo changes or course name updates, very easy to just change that in one place, and then everywhere else would see that change. The only thing with Postgres is there was a little bit slower query times originally, also with joins now, as there's multiple tables. Um, so I introduced B-tree indexing on the courses column in the reviews table, as that's where all the lookups were happening, and I didn't want to introduce too many indexes on the table. I wanted to make sure that I was being efficient with those, as I wasn't creating unnecessary overhead with those. But the B tree index on the courses column really ramped up how efficient the queries were. I ended up getting to roughly under 10 milliseconds searching for all the related reviews or associated reviews to a given course, joining those tables and returning all that information. So really, um, Postgres worked great. It normalized the database. It allowed for a single source of truth, and I was able to use indexing to get queries down to under 10 milliseconds, which was great. So that is what I'll be using going forward. Yeah, thanks.